Hello students, today for the agenda you will be checking your homework. You're going to have a warm-up and we're going to learn rational exponents, but now we're going to be going from decimals to fractions so that we can then convert it to roots, and you will be working on 8.6. So students will be able to convert a rational exponent to a root by first converting the exponent from decimal to fraction, because in the last lesson we already learned to convert rational exponents as fractions to roots. Okay, with a warm-up, and you might want to pause this video because I'm just going to give you the answers. Okay, but to convert to decimals, all you have to do is divide the numerator by the denominator, and whatever you get, that's your decimal. Converting to fractions, all you do is put this over 1 with that many zeros. So in this case it would be 6 over 10. Okay, so pause it, and I'm now gonna give you the answers, and I guess you can see the processing here. So basically, when we divide 3 by 4 is 0.75. When we divide 1 by 2 is 0.5. When we divide 2 by 3 is 0.66666 infinitely. And that's when we put a line on top of the decimal. 1 divided by 8 is 0.125. In here, remember that I told you that you put the number that is after the decimal over a 1, and then how many spaces do I have? 1, so 1 0. And then both of these are divisible by 2. So 6 divided by 2 is 3, 10 divided by 2 is 5. In here we have 2 decimal places after the decimal point, so it's going to be 12 over 1 2, so a 1 with 2 zeros. In here is 370, oh, and then you simplify, of course, and you end up with 3/25. For this one is 0.375. You just put the 375 over, again, because there are 1 2 3 spaces after the decimal point, you have a 1 with 3 zeros, and you simplify. That's how you convert from decimals to fraction. For this one, you get the whole number, which is 15, but you only have 1 decimal place, so it's only 1 0. So whenever you have whole numbers, that's when you end up with improper fractions. Okay, and 15 divided by 5 is 3, 10 divided by 5 is 2. In here is the process that we did, and I'm just going to show you the example for one of them, but then you can try the other ones. Okay, so in here, let's see, 3 divided by 4, 3 divided by 4, we didn't have this 0, so how many times is the 4 going to 3? 0 times. Put a decimal point and add a 0 that doesn't exist. How many times the 4 going to 30? 7 times. 7 times 4 is 28. Subtract and you end up with 2. Bring down another 0. How many times is the 4 going to 20? 5 times. 5 times 4 is 20, and you end up with 0 as remainder. So that's the answer. Now we're going to do rational exponents. Now that we know how to do decimals to fractions, we can start with our lesson. So if we have x to the 1/2, we're going to convert that to a fraction so that we can then convert it to a root. Okay, so remember that we are going to keep the same base. This is going to be 15 over 10. If we simplify, we can simplify by dividing both by 5, and so it's going to be 3/2, because 15 divided by 5 is 3, 10 divided by 5 is 2. And then from here we can go to the root, which is what we learned in the previous lesson. Remember that we keep the same base. Okay, and this becomes the exponent, the numerator becomes the exponent, and the denominator becomes the index. Remember that we don't write an index of 2. Okay? So that will be the answer. Now we have x to the point 3. So that is 3 over 10, just like in our warm-up. 3 over a 1 with 1 0. Okay? And we don't need to simplify it because it's already simplified, so we can go directly to the root. We keep the base. This is the exponent, and 10 is the index. I'm doing some so that you can just see the pattern. So remember that for decimals to fractions, all you do is put the number over a 1 with how many zeros? 1 0. We can simplify it because both are divisible by 2. And so 4 divided by 2 is 2. 10 divided by 2 is 5. And so now I can write it as a root, keep the same base. The 2 is the exponent, and the index is 5. And I think you get the hang of it. Maybe you want to pause this one so that you can try it on your own. Pause it right now. So you write the number on top of a 1 with only 1 0. Both are divisible by 5, and so it's going to be 1/2. I also mentioned before that whenever you have a number that is in the numerator that is half of the denominator, is always going to be simplified to 1/2. So now I just put x. Remember that exponent 1 we don't use, and index 2 we don't use. We assume already that it's right there. Okay, let me do this one really fast, and if you want you can pause it. It's over 10, which is simplified to x to the 3/5, right? Because 6 over 10. And so the root would be keep the base, the numerator is exponent, and the denominator is the index. We can also convert from a root to a fraction and then to a decimal. Let me write this from decimal, exponent, to fraction exponent. And so both of these are called rational exponents, okay? To a root. Okay? Now I'm going to do from root to fraction to decimal. Okay, from root to fraction to decimal. Okay, and so we have the square root of x. Oh, look at that. Square root of x. Remember that x stays the same. The exponent becomes the numerator. The index becomes the denominator. So it's x to the 1/2. And 1/2 in decimal form is 0.5. Okay. If we have this root, we keep the same base. The exponent becomes the numerator. The index becomes the denominator. And so this is one of those that I want you guys to remember. 1/4 is 0.25, just like 1/4 in a dollar. And 3/4, 3 out of 4 quarters, it's 75 cents. So 0.75 would be the decimal. And if you don't remember, you can just divide all the time, okay? Okay, one more. So this is keep the base. The exponent is the numerator. The index is the denominator. So x to the 0.25. Okay. So I think like by this point you might be like, oh, I get it, because you have seen so many examples in the previous lesson as well with this one. And if not, again, you can just go over the videos again and again. Oops, and if you notice, this is the root, this is the fraction, and this is the decimal form. Okay, now I'm going to show you with a calculator. So we're going to create a table now so that you can apply a little bit of the skills on the calculator. And we're gonna have the input, which is x, and the output, which is y, just to practice some of this on the calculator. Okay, so here we have 16 to the 0.1, 16 to the 0.2, 16 to the 0.3, 16 to the 0.4, 16 to the 0.5, 16 to the 0.6. Later on, we're going to be finding this in graphs of real life situations. So on a table, what you're going to do is write the base, which in this case will be 16. Okay. And of course, they say write the button 1 or key, the 6, press the button. And in some cases, it looks a little bit different. Sometimes they say x to the x or x to the y. No, we ran out of battery. I apologize for the technological difficulties. I have one online that it only, I don't have enough space for both. Maybe go the other way around. Sorry about that. It's good because that way you can just go calculator and then you can have it online and start using it. So you're gonna press the 1, the 6, then there is this key. If you see x to the y, and as I mentioned, sometimes it's y to the x, which is basically just switched. Okay, you press that, and then you press the exponent that you have in there. In this case, it's 0.1. So equal, and that'll give you the answer. So for now, I just want you to round to the nearest tenth, maybe hundredths. We'll do the hundredths. Round to the nearest hundredths. The first one is tenths, hundredths, so you need to look at the thousands to round this. If the thousands place has a 5, 6, 7, 8, or 9, so 5 and above, then this goes up 1. But if it's 4, 3, 2, 1, then this stays the same. So in this case, the thousands is a 9, so this is going to go to 1.32. 1.32. And so let me show you. Let me move this to the side. So what I did is press the 1, press the 6, press the power key, which is y to the x or x to the y, and then you're going to press the decimal point because we have a decimal in the exponent, and the 1, and finally the equal sign. Okay, so it's very simple. So again, the base, which is 16, the x to the x, x to the, or in here x to the y, the exponent, which is 0.2, and equal, so it's going to be 1.74. The reason for which this didn't change is because this is less than 4 or less. Okay, if this is for the thousands place is 4 or less, this stays the same. Okay, for the next one is 16 to the power of the exponent and equal. It's going to be 29 rounds up to, because of the 7, rounds up to 30. So basically it just ends up in 3. 16 to the power of 0.4 equals 3.03. 16 to the power of 0.5, and so that will be 4. Later on, we're going to see a relationship in here. 16 to the power of 0.6 equals 5.28. Okay, so if you recall, 16 to the 0.5 is the same as 1/2, right? 0.5 is 1/2. And this is the square root of 16. This is the exponent. This is the index. So what is the square root of 16? Well, one number multiplied times itself is 16. Well, that will be 4. So 4 times 4 is 16. So therefore, if you notice, whenever you have either half or a 1 or a 1.5 or a 2, you are going to end up with a whole number as an answer, and that's because those are going to be perfect squares. That's if the base is a perfect square. Okay, so I hope this lesson helps. Now you are able to do 8.6.